Yeah, hello everyone. I'm Vincent Lee from Cloud Business Department. AIC is happy to launch the latest 2U4 server nodes in one chassis on both Intel and AMD platform against density and the virtualization application requirements. Next page, please. Next. MEC Mobile Edge Computing. AIC 2U4 server node platform is the best solution for the latency-sensitive mobile edge computing workload, and at the same time to meet the space limit conditions at the edge size. HCI, hyper-converged infrastructures. It is a high-density design for combining the computing, storage, and network in one compact chassis against HCI environments. HPC support maximum 8 CPU, 64 memory slots, 24 NVMe U.2, 12 PCIe by 16 adapters in one 2U chassis. Next page. Yeah. AIC 2U4 server nodes platform is giving 4 different SKUs as this page showing. The first one is the HP201VL. It is supporting 2U4 server node in one chassis. Each node is supporting 6 U.2 hard swap plus 2 SATA 2.5-inch internal plus 2 SATA or PCIe M.2. It is supporting dual Intel CPU and CPU TDP is up to 165 watts. Totally supporting 16 memory slots, 3 PCIe by 16 slots, and supporting either 1600 watt or 2000 watts 1+1 redundant BSU. The depth is 780 millimeters. The second one is the HP202BL. This is the same Intel platform as the first one, HP201-BL, except each node is supporting 3 SATAs, 3.5-inch or 2.5-inch in front. That is a hard swappable. The third one is the HP201-AG. This is the AMD platform. So each node is supporting 6 U.2 hard swappable plus 2 SATA 2.5-inch internal plus 2 SATA or PCIe M.2. And it is supporting single AMD CPU and the CPU TDP up to 180 watts. And each node is supporting 8 memory slots, 3 PCIe by 16 Gen 4 slots on each node, and the same design as the Intel platform, either supporting 1600 watts or 2000 watts 1+1 redundant power supplies. The last one is the HP202AG. This is the same AMD platforms, but that is supporting 3.5-inch 3 by 3 for each node. All other specs are the same as the HP201-AG. Next page, please. Yeah, to summarize, AIC 2U4 server nodes key feature that is supporting high storage density, high expansions, and high flexibilities. So for each node, that is supporting 2 SATA NVMe M.2 and the 2 SATAs 7mm SSD plus 6 hard swappable U.2 NVMe in front or 3.5-inch HDD. High expansion means each node is supporting maximum 3 PCIe slot by 16, which is including 2 half-lengths plus 1 OCP 2.0 maximum. And for the AMD platform, it is supporting the Gen 4 interface. High flexibilities. Our platform is supporting both Intel and AMD, and either supporting 25 2.5-inch or 12 3.5-inch. That's many storage options, either supporting 6 U.2 swappable, or 4 UDA2 plus 2 SATAs swappable in front, or even the SATA and the SAS by 6 in front for each node. And also the PSU, that's an option for the 1600 watts in order to save in the energy, or you can choose in the 2000 watts. Next page. Yeah. We were designing the same 2U4 server node platforms on the next generation based on the Intel Ice Lake or AMD Milans. That will be to follow the same spec as the current generations, but that will be available on the year 2021. So next one, I will show you some the physical servers for your more understanding. The first one is an Intel server node platform. Each server node is supporting 2 CPU sockets with 16 memory slots maximum. And it is also supporting 3 PCIe by 16 slots, which are including 2 2.5 heights, half length slots. Plus 1 OCP 2.0 PCIe by 16. And the server node is including 2 M.2, either for SATA or PCIe interface. With AIC mixed I/O design patterns, it is supporting cableless design to extending the PCIe length from the board labels to the SSD. And also, based on the cableless designing, the server node its design can be hot swappable without system interrupts. The second one is the AMD platforms. Each server node is supporting 1 single socket with 8 memory slots maximum. It's the same design with 3 PCIe by 16 slots supporting, which including 2 half heights, half lengths, plus 1 OCP 2.0. All the PCIe store is a Gen 4 interface. On board is also supporting 2 M.2, either for SATA or the PCIe interface. That is also with the same cableless designing to extending all the interface from the board label to the front device. And that's also same cableless design for server nodes hot plug without system interrupt supporting. Next one is chassis bodies. It is supporting either 24 2.5 inch or 12 3.5 inch device. All the storage device designed by AIC, which is the school is supporting. .5 inch with a screw design also. And each node is supporting individual power buttons and LED for the system status alerts and the indications. The system is supporting 1600 watts or 2000 watts as options. And with the AIC special design, with AIC special designing, Each server node is with an additional two 7mm SSD device supporting. Either it's supporting OS or the cache purpose. And this storage carrier is also the toolless design. And for the cooling systems, all the fan is a hot swappable, which can be easily for maintain and exchange. All right, thank you for watching. If you have further questions, please visit our website or contact regional sales for more information.
Hello, everyone. I'm Simon Chang-Woo, BDM from Cloud Data Center team. And today, I would like to talk to you about one of the use cases for AIC 2U Phono server. AirDeck is a HCI solution from our customer. Combining the software and AIC 2U Phono server, we can solve some problems existing in the mainstream HCI solutions today. So before we begin, let's take a look. In the traditional virtualized environment, you have a hypervisor cluster. Attached to that cluster, you have different type of storage appliances. Depending on your application, you will draw storage from different types of storage. This is very flexible, and but at the same time, there are some problems. The hypervisor cluster and each storage appliance have their own software management system and hardware configuration as well. So this system is hard to learn and even harder to manage. It is also very complicated to scale. It will take days, sometimes even weeks, to plan and execute. To solve this problem, hyperconverged infrastructure was proposed. Now that you have a uniform hardware hosting all your compute, network, and storage resources, users can easily manage and scale. However, this type of HCI often only provides a single tier cache storage pool with a scale-out architecture. The users still has to run different types of applications ranging from archiving to high-performance database. So can this one type of storage fulfill all different types of applications? With that in mind, AirDeck proposed a different type of HCI architecture. This architecture will combine the flexibility of traditional virtualization and the convenience from hyperconverged infrastructure. In order to achieve this, three features have to be supported. They are multi-tier storage, configurable resiliency policy options, and heterogeneous hardware support. And with these features, you can have a HCI solution that provides many storage options that adapts to different applications. So AirDeck solution was designed to aggregate different types of storage media in the cluster into different storage pools. The virtual machines can then draw storage from different pools according to the application requirements. Each virtual machine can even draw from multiple pools at the same time. This means that the users can decide the ratio between the cache tier and the capacity tier that's suited best for the application. So AirDeck also provides different types of resiliency policy. Users can choose from a single copy or multiple copies across the nodes or erasure code. The single copy VM disk can provide the highest performance, but it offers no data protection. And the replica policy allows the user to protect their data with minimum performance penalty, but at the expense of disk space. And the erasure coding policy allows users to protect their data with minimum disk space overhead, but at the expense of performance. So basically, depending on your application requirement, you can choose different type of policy that's suited best for the application. So before the storage can be consumed by the virtual machines, the user must create a virtual storage, right? And when the user, during this creation process, the user can assign the type of physical storage that they want, and then also choose the type of resiliency policy to apply to the virtual storage. Once the virtual storage is created, the user can allocate storage from this virtual storage. And also with different type of storage media and different type of resiliency policy, there are many combinations available to create this virtual storage. So last but not the least is the support for heterogeneous hardware. With this feature, the user are no longer restricted to adding nodes with the exact same configuration of the original cluster. They can add only the resource that they need. And also another benefit is that when the new generation of technology becomes available, the users can also add that into the original cluster, so their investment is protected. Now, why did AirDeck choose AIC 3.0 platform? Because our HP202BL has a robust design that supports a high density of the compute and different type of storage media. At the same time, each node also comes with a 3 PCIe by 16 slots that can fulfill the network requirement of the solution. And this is how users can enjoy the convenience of HCI and flexibility of different storage options at the same time. There are also other use cases, for example, using HP201BL, which has a 24U.2 NVMe SSD instead of 12 hard drives, for applications that requires high performance from the NVMe SSD. AirDeck can extract better performance from the NVMe SSD by using replica or single copy policy. And that is in comparison with the mainstream HCI solution, which usually only supports distributed storage. Now, I would like to also show you the user interface. Okay, so this is the AirDeck user interface. So after we sign in, you can see the dashboard. Here is the drop-down menu. There's a department because AirDeck supports multi-tenancy, and this is where you can manage the privilege of different organization and user and project, etc. Okay, and the first section here is the physical resource, and the second section here is the virtual resource. So here you can see the status of all your nodes in the cluster and the CPU and memory utilization, etc. And also you can power cycle or quarantine the nodes. The free nodes page is basically where you can discover new nodes and add them into your cluster. So this is where you can check the status of your physical network. And this is where you can check the status of your physical storage. So as I mentioned earlier, we can pour different storage into different tiers, physical storage pools, and then create virtual storage out of them later. Okay. And here you can see the virtual storage that already existing, already being created on these storage pools. Okay. And here is where you manage all your virtual machines. Okay, there are many virtual machine management features such as snapshot, VM image. You can do different actions to your virtual machines and manage your virtual volumes. You can do instant snapshot or schedule snapshot, and you can attach a floating IP, etc. to your virtual machine. And this page is the virtual network. So you can create virtual routers and configure security groups for your virtual machine. Okay. So this is where you create your virtual storage. So as I mentioned earlier, during the creation process, you would choose the type of physical storage that you want to draw from, and then the type of policy that you want to apply to the virtual storage. So as you can see that there are actually many different types of pools that have been created already. For example, these three pools all draw from the performance tier, but they have a different replica configuration. Okay, so this is how you can mix and match physical storage and a policy to create a virtual storage that's dedicated, that's suited the best for your application. Okay, so when you consider cost and performance, and this is very, very flexible for your application requirements.